Welcome to Reduced Environmental Impact Textile Products, an open educational resource part of Block 6 Sustainability, developed by Materially, an international agency specialized in consulting and scouting solutions for innovation starting from materials. Determined by the increased speed with which nowadays it is possible to manufacture garments and accessories, and consequently fashion is delivered to consumers, paralleled by a significant fall in prices, in only a few decades a rise of 40% of the amount of clothes bought per person in the EU has been registered, causing fashion clothing purchasing habits to shift to clothing consumption habits. All processes involved, raw materials production, fiber spinning, textiles weaving, dyeing and finishing, require enormous amounts of water and chemicals as well as energy, with the majority of clothes production taking place abroad. In order to reduce the textile industry's environmental impact, a variety of aspects has to be carefully considered, and efforts should be aimed at implementing or increasing recycled contents and/or bio-based contents from easily and sustainably renewable resourcing, adopting or improving sorting and recycling technologies and processes, as well as wastewater-related good practices, reducing the use of toxic substances and processes, and enabling virtuous end-of-life options. The textile industry plays a crucial role in the global economy, and reducing its overall environmental impact also means safer and healthier working environments for hundreds of millions to which the significant sector provides employment on a global basis. In order to illustrate how the ecological footprint of textile manufacturing can be reduced, a selection of case studies of commercially available products and processes has been evaluated, focusing on fibers, yarns and textile products, dyes and dyeing processes, finishings, end-of-life options. This OER offers an introduction to the different aspects of the textile value chain that have a direct or indirect impact on the environment. The case studies presented in the following slides illustrate how technological innovation can contribute to reduce the ecological footprint, starting from raw material supply, production and transformation processes, final material composition and application. Let us begin with fibers, yarns, and textile products. While the global market is offering a growing variety of fibers, yarns, and woven and knit textile products featuring post-industrial and post-consumer recycled contents, choosing recycled raw materials, biological or technical nutrients, does not represent the only way to reduce a fabric's environmental impact. In addition to the adoption of recycled and easily recyclable fibers, options include fibers and yarns manufactured with high-performance biopolymeric yarns from easily renewable resources, which are non-food crops. Our first case study is a recycled performance polyester fiber manufactured with PET from recycled materials, including post-consumer drink bottles. The filaments produced are comparable in every way to virgin polyester, including physical strength, processing techniques, and visual quality. These fibers can be woven, knit, or used in non-woven processes to make all types of textiles. Fibers are offered as either continuous filament, staple fibers, or spools of yarn. Next is a continuous PLA filament yarn manufactured with a biopolymer synthesized using plants like corn, cassava, sugarcane or beets to capture and sequester CO2, transforming it into long-chain sugar molecules. This yarn product is originated from renewable resources and is 100% biodegradable and 100% compostable. Starting with the extraction of starch, lactic acid is obtained, which is then transformed into lactide and finally polymerized into PLA. Fiber properties are highly competitive, and the reduction of water consumption per kilo of yarn exceeds 600%. Dyes and dyeing processes. In addition to the main constituents of textile products, fibers and yarns, dyes used for different types of fiber and employed at different stages of the textile production process may contribute to reduce a textile's environmental impact. Depending on fiber, yarn, textile, construction and garment, as well as fiber, dye lot size and quality requirements the dyed fabric must satisfy, textile materials can be dyed using different processes, typically batch, continuous or semi-continuous. Colored, organic, surfactant, toxicant and chlorinated compounds and salts represent the primary pollutants in textile effluents, to which up to 200,000 tons of dyes are lost every year during dyeing and finishing operations due to process inefficiency. The textile industry consumes a substantial amount of water in its manufacturing processes. Water is primarily used for dyeing, rinsing, and finishing operations, or for the application of auxiliary chemicals. Resulting volumes and composition of the general effluents make the wastewater from textile plants the most polluting of all industrial sectors. Therefore, plant-based dyes and waterless dyeing solutions represent sustainable options. Cotton dyeing is one of the most chemically intensive industries. Generally, cotton and dye are both negatively charged, and this repellent behavior creates the need for significant amounts of natural resources, high temperatures, toxic chemicals, and long cycles to force them to bond together. This sustainable, cost-effective, and more efficient solution is based on the application of a patented permanent treatment to raw cotton that creatively changes the molecular structure of cotton to a positive charge, thus generating a natural attraction to dye. During dyeing, the treated cotton requires far less water, energy, time, and toxic dyes and chemicals. The fiber's specific properties allow it to be dyed in innovative colors and patterns that would otherwise be too costly and take too long to manufacture. Moreover, this technique reduces the amount of water needed to produce cotton, which normally is 10,000 liters of water for dyeing just 1 kilo of cotton. This new range of cotton textiles brings out the color of food through food-derived dyes. Using a patented technology, it recreates gentle food hues by taking vegetables and other leftover food from local food processing companies that is typically discarded otherwise and converting it into dyes. The dye contains over 90% natural ingredients. Finishings. In order to improve or modify the physical performance and sensorial qualities of an existing textile product, its appearance, performance, hand and functional properties, different finishings may be applied through a series of processing operations. Performing wet processing techniques typically implies consuming a lot of energy and water, making the water and carbon footprints of these procedures extremely high. Furthermore, vast quantities of complex and frequently potentially hazardous chemicals are often used. In addition to being based on improved sustainable formulations using natural ingredients, water-free technologies and further potential substitutes for water and chemical-intensive wet fabric finishings should be suitable for a variety of textile product types and possible not require specific equipment and significant investments, since easy to implement, effective procedures have greater chances of being acquired. This water and stain repellent finish for textiles mimics the natural protection of ducks and other waterfowl. Ducks produce an oily secretion that allows their plumage to repel water. This finish mimics this natural impregnation through a very fine film of biodegradable paraffin chains that wrap and bind themselves spiral-like around individual fibers, filaments, or yarns. This finish is based on renewable primary products, agricultural products not used for foodstuffs or animal feed, which do not include genetically modified plants. This drapery and upholstery fabric is made of 70% viscose and 30% linen that is both flame retardant and biodegradable. A molecular modification of the cellulose causes the fabric to carbonize, binding oxygen and therefore controlling the flames. The textile protects naturally against fire and fulfills all standard tests for flame retardancy. Furthermore, these fabrics exhibit intrinsic hygroregulating properties and are hypoallergenic as well as antistatic. End-of-life options. Manufacturing sustainable textiles also implies carefully designing their end-of-life destination. Typical solutions rely on simple or optimized recyclability and/or compostability, and on the possibility of making textile products with mixed compositions easily separable into their distinct fibers, layers, or constituents. Advanced solutions include the possibility of switching from one cycle to another, for example from a technical cycle to a biological one, by using raw materials from the technosphere to manufacture textile products meant to end as nutrients for the biosphere. This recycled biodegradable synthetic insulation and fabric is made from 100% post-consumer recycled material, and its fibers break down without affecting their performance characteristics when exposed to specific environments, such as the landfill or the ocean. The fibers have been enhanced to be more attractive to the naturally occurring microbes found in these environments, which eat away the fibers at a faster rate, returning the fabrics or insulation to natural elements. The biodegradation process leaves behind water, methane, CO2, and biomass. This short OER provided a series of case studies to illustrate how technological innovations in the textile production and finishing processes enable to reduce the environmental impact of the final textile product. Please visit testextproject.eu to see the rest of the intellectual outputs of this project. Thank you for your attention.